Thomas.
Once again, welcome. Here we are with chapter 1, lesson number 4, looking at algebraic long division. Now what on earth is algebraic long division, I hear you ask? What's algebraic long division? Well, if you have an improper fraction, that can be expressed as the sum of a whole number and a proper fraction. For example, if you've got this improper fraction here, 13 over 5 is improper or top heavy because the top is larger than the bottom. So 13 over 5, you could write that as 2 3/5. So there's 2 wholes you can take from that, and then you'd be left with 3/5. So that's an example of an improper fraction. Let's mix this up though and let's get an improper function or a proper function. Well, what's meant by that? Well, this function here, your x take away 1 over x squared take away 3x plus 5, that's an example of a proper rational function. And it's proper because the degree of the numerator is less than that of the denominator. And when I talk about the degree, I mean the highest power of x. So here in the bottom, the highest power of x is 2, it's x squared. Here, the largest power of x is x to the power of 1, or just x. The top is smaller than the bottom, so that's a proper rational function. This example here though, if we've got x squared plus 6 over 2x plus 7, what could you say about that one? Excellent, yes, improper, because the degree of the numerator, the highest power, is an x squared. On the bottom, you've got x to the power of 1. Well, the 2 is obviously bigger than 1, so that'll be your top heavy fraction. Or, it's an improper rational function. And as it says, the degree of the numerator is greater than that of the denominator. Or what you could also get is it could also be equal. So if we had 2x squared on the bottom, well, that would also be an improper rational function because the degree of the numerator and denominator would be equal. Okay, so when it's equal or greater than, it's an improper rational function. What you can do with an improper rational function is you can express them as the sum of a polynomial and a proper rational function using something that is known as algebraic long division. How do you use algebraic long division? What is that? Well, we'll get onto that, but for algebraic long division, I like to think of my wee buddy, my wee friend. He's a friend to me, he's a friend to you, he's a friend to all of us. It is, no, it's not Mrs. McNamara, although it does look a bit like her. It is Dracula. And what do you remember when you think of algebraic long division? Well, you think Dracula must suck blood. Dracula must suck blood. If you remember that, you'll remember how to do algebraic long division very, very easily. D for Dracula. D also stands for divide. M in maths, M stands for multiply. S, what does that stand for? Subtract. And B stands for begin again. Yes, a bit rubbish that one, but it stands for begin again. So Dracula must suck blood, divide, multiply, subtract, begin again. When you do this, you are going to be dividing and you'll end up with something that looks like this, which is mighty confusing, but I'll go into some examples and show you how it is done. So example 1. Express x squared plus 2x plus 4 over x plus 1 as the sum of a polynomial and a proper rational function. How on earth do we do that? Well, what we're thinking is we've got x squared plus 2x plus 4 and we're dividing it by x plus 1. So we're going to set this out using our wee dividing step or our bus stop or our lorry or whatever on earth you want to call it. So we've got x squared plus 2x plus 4 and we're dividing it by x plus 1. So for this, think Dracula must suck blood. D for Dracula, D for divide. So we divide, and it's always, as it says here in green, the first terms. So if you do x squared divided by x, what does that give you? X! Brilliant! So that's an x, so we write that in the top. You know, you write your answers just on the top here. So that's an x. Dracula must, M for multiply. So multiply, and you multiply the x by the x plus 1. So x times x will give you x squared. X times 1 gives you x. And you write them just in a row. So the x squareds are above the x squareds, the x's are above the x's, and any numbers would just be above any numbers that you have. So x times x is x squared, x times 1 is x. After that, well, there's nothing else there. What do you then do? Dracula must suck. S for subtract. So we're subtracting, so we draw a line under here. And you subtract. So x squared take away x squared gives you 0x squared, so you don't need to write that. 2x take away x, well, that will give you x. And 4 take away 0, that gives you 4. So we've got an x plus 4. Dracula must suck blood. B for begin again. So off we go. So we're dividing once again, and again it's your first terms. So the first terms here, well, you've got an x, and again we're dividing it by this x plus 1, but just the first terms. So x divided by x will give us 1. Good, so that's just going to go above the number here, so that'll be a plus 1. D for divide, M for multiply. So now we're taking the 1, and we're doing 1 times all of this. So 1 times x will give us x, and 1 times 1 will give us 1. So we've got an x plus 1. From there, Dracula must suck. S for subtract. So we've got the 2 lines, so we draw a line under there and we subtract. So x take away x will give us 0x. Don't bother writing it. And 4 take away 1 is obviously 3. From there, well, we can stop because the degree here is less than that of the divisor, the bit we are dividing by. So we know we can stop here. What we have down here is the remainder. You know, when you divide, you're going to get your answer, remainder, something. So this bit here is your remainder, and this bit at the top is your answer, where your answer is traditionally written. So if we are writing this x squared plus 2x plus 4 over x plus 1 as the sum of a polynomial and a proper rational function, well, the polynomial part is just our answer. So the polynomial part will just be this, the x plus 1. So that equals x plus 1. And the proper rational function, well, because we're dividing by x plus 1, that's not changing. That's going to stay as divide by x plus 1. But what would the top of the fraction be? Well, at the top of the fraction, you just have your remainder. And the remainder is 3, so we're going to have 3 over x plus 1. It does take a bit of time to get used to this with the algebraic long division, so there's quite a few examples here. So move on to the next one, have a look at that. Example 2, express x cubed plus 4x squared, take away x plus 2 over x squared plus x as the sum of a polynomial and a proper rational function. So, very, very similar to the last one. Again, we're dividing the top by the bottom. So we're dividing this x cubed plus 4x squared, take away x plus 2, by x squared plus x. For this then, again, Dracula must suck blood. So D, Dracula, D for divide. So you divide the first terms. So the first terms here, let's go with x cubed, and we're dividing it by x squared. So x cubed divided by x squared will give us x. So we're going to write an x here, just on the top. Dracula must, M for multiply. So you take your x and you multiply by everything here. So x times x squared and x times x. X times x squared gives you x cubed, and x times x gives you a positive x squared. So we've got plus x squared. From there, Dracula must suck. S for subtract. So draw a line. Every couple of lines you will draw a line and you'll subtract. So x cubed take away x cubed gives you 0x cubed. You should always get 0 when you subtract those first terms there. If you don't, you've made a mistake somewhere. So x cubed take away x cubed will give you 0. 4x squared take away x squared will give you 3x squared. Negative x take away 0x gives you negative x. And 2 take away 0 is going to be 2. From there, Dracula must suck blood. B for begin again. So after you draw a line and you subtract, you're wanting to start again. So this time, you're wanting to, again, use your first terms, and we've got the 3x squared, and we divide again by this first term. So 3x squared divided by x squared will give you positive 3. So it's an answer, so you write at the top, plus 3. D for divide, M for multiply, Dracula must. So this time we are wanting to take the 3 and we're multiplying by everything here. So 3 times x squared and then the 3 times the x. So 3 times x squared gives you 3x squared. 3 times x gives you plus 3x. That's all it gives you. After that, Dracula must suck. S for subtract. So every couple of lines you draw a line and then you subtract. Remember, first term should always give you 0. If they don't, you made a mistake. So 3x squared take away 3x squared is 0x squared. Woo! Negative x take away 3x gives you negative 4x. And 2 take away 0 gives you 2. From there, you want to look at what you have. We've got a negative 4x here, and we'd be dividing that by x squared plus x, but the degree of this is less than that of this. So we can stop, and really down at the bottom here, you have your remainder. So this is remainder. We can now stop since the degree is less than that of the divisor. From there then we can express this function here as the sum of a polynomial and a proper rational function. Really, the polynomial is just the answer. So the answer at the top is x add 3. So that's going to be equal to x add 3 plus, and then what are we left with? Well, we're left with a remainder of negative 4x add 2. So we'd have negative 4x add 2. And we'd be dividing that by, well, dividing right the way along by the x squared plus x. And that is not changing. Just make sure you do not take the negative outside. If you did, you'd have to take negative 1 out of the whole of the top line and then bring it down. Don't just put the negative there and then have negative 4x plus 2. That wouldn't make any sense. Okay, you best to just leave it as plus, and then you've got negative 4x plus 2 over x squared plus x. Let's try another example. Example 3. Express x cubed take away 2x plus 5 over x squared plus 2x take away 3 as the sum of a polynomial and a proper rational function. Yeah. So for this one, we've got x cubed take away 2x plus 5. That is going to go under our dividing step. Just make sure that because there are 0x squared terms, we write down 0x squared. And we're dividing that by x squared add 2x take away 3. So that's just going to go to the left here. After that, Dracula must suck blood. So we're wanting to divide, D for divide, and you want to divide the first term. So x cubed divided by x squared. If you do that, x cubed divided by x squared, well, that's going to give you x. After that, you're wanting to multiply. Dracula must, m for multiply. So x times x squared, x times the 2x, and x times this negative 3. If you do that, x times x cubed, x squared gives you x cubed, x times 2x gives you plus 2x squared, and x times negative 3 is negative 3x. After that, Dracula must suck. You know, every couple of lines you will draw a line and you will subtract. Remember, the first term should always cancel out. If they don't, you've made a mistake. X cubed take away x cubed is 0x cubed. Don't bother writing it. X squared take away 2x squared is negative 2x squared. Negative 2x take away negative 3x will be negative 2x plus 3x, which gives you positive x, and 5 take away 0 is going to be 5. From there, well, Dracula must suck blood. We begin again. How do you know we begin again? Well, if you look at the remainder here, the degree is the same as that of the divisor. If it's larger than or the same, you keep on going. You will begin again. So for this one, again, you're taking the first term. So you've got the negative 2x squared, and we're dividing by x squared. For that, negative 2x squared divided by x squared gives you negative 2. It's an answer, so you write it at the top. From there, we're now looking at this negative 2. And you do negative 2 times each of these 3 terms. So negative 2 times x squared gives you negative 2x squared. Negative 2 times 2x gives you negative 4x. And negative 2 times negative 3 gives you positive 6. Dracula must suck. So you subtract. Draw a line and then subtract. So negative 2x squared take away negative 2x squared will become plus, which will cancel out, which will give you 0. X take away negative 4x will become x plus 4x, which is 5x. And 5 take away 6 is negative 1. From there, look at the remainder. You can see the degree is less than that of the divisor, so you can stop. And what you have there is the remainder. The degree is less than that of the divisor. Therefore, if you're asked to write that as the sum of a polynomial and a proper rational function, you can say then that that equals the polynomial is just your answer. Up here we've got an x take away 2. And the proper rational function, the denominator is not changing. It's still going to be x squared add 2x take away 3. But the numerator, the top of the fraction, is just your remainder. And the remainder here is 5x take away 1. And that will be your answer. Example 4, express 3x cubed take away 2x squared plus 6 over x squared plus 4 as the sum of a polynomial and a proper rational function. Again, very similar to the other questions. So we're dividing this 3x cubed take away 2x squared plus 6. Just remember, there are 0x terms, so write that in as 0x. And we're dividing that by x squared plus 4. So we're going to x squared plus 4 here. Dracula must suck blood, so D for Dracula, D for divide. Remember, it's always the first terms. So 3x cubed divided by x squared. If you work that out, well, that will give you 3x. Just right above the x term, just keeps everything neat. From there, you're wanting to multiply. Dracula must, m for multiply. So 3x times the x squared and 3x times the 4. Work that out. 3x times x squared gives you 3x cubed. 3x times 4 gives you plus 12x. Again, I'm just keeping everything in line here just to keep it neat. From there, well, Dracula must, we've multiplied out, and because we've got two lines, we draw a line and we now subtract. So subtracting here, 3x cubed, take away 3x cubed is 0x cubed, it's just 0, don't bother writing it. Remember, the first term should always cancel out. If they don't, you've made a mistake. Negative 2x squared, take away 0, it's just negative 2x squared. 0 take away 12x is negative 12x, and 6 take away 0 is just 6. So we have subtracted. After that, Dracula must suck blood. B4, begin again. Have a look. You've got the remainder down here. You've got your divisor. Well, the degrees are equal, so you keep on going. So, D for divide. Remember, it's always the first terms. So negative 2x squared divided by x squared will give you negative 2. So at the top, you can write down negative 2. Now what we're taking is that negative 2, and we're multiplying that by each of the terms here. So negative 2 times x squared will give you negative 2x squared. Negative 2 times 4 gives you negative 8. And that's all it gives you. From there, Dracula must, we have just multiplied, so you subtract. Every couple of lines, draw a line and subtract. So negative 2x squared, take away negative 2x squared, will become plus. It will cancel out, giving you 0x squared. Negative 12x, take away 0 is negative 12x. And 6 take away negative 8 will give you positive 14. After that, the degree here of this remainder is less than that of the divisor, so we can now stop. So, if we're asked to write this as the sum of a polynomial and a proper rational function, we can say that is equal to, well, you can see here that your answer is 3x take away 2. So that will equal 3x take away 2 plus, and to get the proper rational function, well, at the very start we were dividing by x squared plus 4, so we're still dividing by x squared plus 4, but what is the numerator? Well, that is just your remainder with negative 12x plus 14. Once again, make sure you don't just write that as negative 12x plus 14. That'll make no sense. You'd have to take negative 1 out as a common factor and then move that down if you wanted to do that. I'm just going to leave it as this. So that will be your answer with your polynomial and your proper rational function. Example 5. Find the remainder when x cubed plus 3x squared take away x plus 3 is divided by x plus 2. So doing this, once again, we're dividing by x plus 2. So you can write down the x cubed plus 2x squared, take away x plus 3, and we're dividing it by x plus 2. From there, Dracula must suck blood. So D for divide, Dracula. So it's always the first term. So x cubed divided by x will give you x squared. So at the top, we've got an x squared. D for divide, M for multiply. So to multiply, you take that x squared and you do x squared times x, and x squared times 2. If you do that, well, x squared times x will give you x cubed. X squared times 2 will give you 2x squared. After that, Dracula must suck. S for subtract. You've got two lines, every two lines, draw a line and then subtract. So x cubed take away x cubed will give you 0x cubed. 2x squared take away 2x squared gives you 0x squared. Negative x take away 0 is negative x, and 3 take away 0 is 3. Dracula must suck blood. We have subtracted, so now we begin again. Or do we? Well, let's have a look. You've got negative x take away 3, the degree there is 1. You're dividing that by x plus 2, the degree there is 1. If it's larger than or equal, you keep going, so begin again. So here, D for divide. So negative x, change the colour of that. So negative x divided by x will give you negative 1. So you can write down negative 1. And then after that, well, you're wanting to multiply. So negative 1 times the x and negative 1 times the 2. So negative 1 times x will give you negative x. Negative 1 times 2 gives you negative 2. Dracula must, we have just multiplied. S, you now subtract. So negative x take away negative x, be negative x add x, which gives you 0x. Don't write it. And then 3 take away negative 2, be 3 add 2, which is 5. You can see here the degree is less than that of the divisor, so we can now stop. And what we have here is the remainder. We're asked to find the remainder when x cubed add 2x squared, take away x plus 3 is divided by x plus 2. Therefore, the remainder would be, Sandy? Yeah, the remainder is just going to be 5. You got it. That's 5 examples with algebraic long division. Give these questions a shot in the Unit 1 booklet, pages 7 and 8. If you still need the booklet, send me an email and I will send it to you. Good luck. Any problems, let me know. Just remember, Dracula must suck blood.